Okay, so which problem do you want me to do? Actually, let's do, where's one that we have to switch both? 13. Okay, let's do 13. I think 13 is the hardest one on there. So we'll do 13 together, and then you guys can do 10 through 12. Okay, so when we're looking at the Pythagorean identities, we're asking ourselves, the ones that they give us, do we have, where are those together in a formula? So for number 13, we have tan, we have sine, and we're looking for tan. So we find those together in this formula. They're not written in the formula, but their reciprocals are here. So what we're going to do here is we're going to say, okay, so if we have the sine, we're going to flip it over and put it in this formula as the cosecant, right? So when I'm looking at number 13, the first thing I would do would be to say, well, the cosecant is 7/3. And then I would rewrite this formula, but instead of cosecant theta, I would write 7/3. So now I'm going to square and subtract the 1. So 7/3 times 7/3 is 49/9. I'm going to subtract 1 from both sides, but when I subtract fractions, I want to have a common denominator. So I'm actually going to call this 9/9 instead of 1. So it's the same quantity, it's still 1. I'm just writing it in a way that makes it easier for me to subtract. So this cancels here. I have cotangent theta equals 49.
Wait, why did you use the cotangent for your...
Yeah, so I'm looking for the tan, and I have my sine.
Oh, I see.
So those are together here in this formula. But we flipped it so we would get the cosecant to plug in. And then once we get the cotangent, we'll flip it again to get the tangent. Okay, so square root to get cotangent. This is going to be radical 40 over 3, right? The square root of a fraction is the same as taking the square root of a numerator and the square root of a denominator. So here's the square root of the numerator, which isn't a perfect square, and the square root of the denominator, which is a perfect square. We can split this into, this is a perfect square, right? And this is what's left. Radical 4, radical 10. This will be all over 3. And I'll move up here so you guys can see better. So the cotangent of theta is going to end up being 2 radical 10 over 3. But, are we wanting the cotangent?
No.
No, we want the tangent. What do we do? Flip it. Can we leave it like that?
No.
Why not?
It's a
There's a radical.
Radical in the denominator. Aw, shucks. Okay, so here we go. 3 radical 10 over 2 times 10, right? Radical 10 times radical 10 is regular 10. Okay, so that's the same thing as 3 radical 10 over 20. Can't reduce that. The only thing we have left to do is check our sign. Is it positive or is it negative? So this is telling us we're looking at, whoops, pi over 2 to pi. So we're in quadrant 2. Quadrant 2 has a negative cosine, a positive sine, and a negative tangent.
That's negative.
It is negative, yes, good. Because we have the tangent.